Assalamualaikum. My name Muhammad Sufyan bin Zaharuddin from BEM Semester 1. I want to present about thermistor. Thermistor is an electronic component used to calculate the temperature. For introduction, this is type of resistor whose resistance varies with change in temperature. These NTC thermistor are made up from the combination of metal oxide which pass through sintering process which give negative electrical resistance versus temperature relationship to it. Due to having a large negative slope, a small change in temperature causes a hard change in electrical resistance. Thermistors are divided based on their conduction model. Negative temperature convection (NTC) thermistors have less resistance at high temperature, while positive temperature convection (PTC) thermistors have more resistance at high temperature. This symbol shows an electrical current will flow into the thermistor and due to the properties inside, a limited amount of it will flow out. What an actual thermistor look like on the side. And this photo are only few basic part of thermistor. Two metal leads to carry a signal in and out. Metal oxide wafer and a protective outsheet made of glass or resin. Sometimes a type of solder is used to help fuse the leads and the core together, but in the manufacturing technique, the outsheet compresses the leads to core enough to keep them in place. At the heart of the thermistor is a core, a disk of metal oxide. This is a compound or combination of oxygen and a metal element, such as nickel, copper, or manganese. Okay, next is technical specification. Thermistors are temperature-dependent variable resistor. There are two types thermistor: positive temperature conversion (PTC) and negative temperature conversion (NTC). When the temperature increases, PTC thermistor resistance will increase and NTC thermistor resistance will decrease. They exhibit the opposite response when the temperature decreases. This is general of thermistor. Resistance 25 degrees Celsius, 10,000 plus minus 1%. B value of material constant 3,950 plus 1%. Dissipation factor approx 7.5 mW per K. Thermal cooling time constant 20 seconds. Thermistor temperature range negative 55 Celsius to 125 Celsius. Thermistor temperature resistance curve negative 40 Celsius to 60 Celsius. NTC thermistor between negative Celsius and 60 Celsius. From graph, you can see that thermistors have high sensitivity. A small change in temperature causes a large change in resistance. Also note that the response of the thermistor is not linear. Okay, that's all for me. I will pass for my team.
There are two types of thermistor, which is an NTC and a PTC. In an NTC thermistor, when the temperature increases, the resistance decreases, and when the temperature decreases, the resistance increases. These are the most common type of thermistor. A PTC thermistor has the reverse relationship. When the temperature increases, the resistance decreases, and when the temperature decreases, the resistance increases. The Steinhart equation is a simple method used for modeling thermistor temperatures easily and even more accurately. The equations for the calculations are as follows, where T is the temperature, R is the resistance. At T, A, B, and C are the Steinhart coefficients, which vary depending on the type and model of the thermistor and the temperature range of interest. Equipment needed to test a thermistor are: number 1, the thermistor that needs to be tested. Number 2, heater, dry blower, or any type of heating device. Number 3, ohmmeter or multimeter. To test an NTC thermistor, firstly check its rated value. Remember to take note that any thermistor, for example, a 10 kilo ohm thermistor, its resistance value should be very close to 10 k ohm. If you are in a relatively warm room, it may be about 9.3. If you are in a colder area, it will be at a higher value. This is the first preliminary test to check whether a thermistor is good. If it is near its rated resistance value, then so far it is good. If it is very far or much different than its rated value, then the thermistor is faulty and should be discarded. The next test is to apply heat to the thermistor. This can be done either by a heater, dry blower, or any type of heating device. When you apply heat to the body of a thermistor, its resistance should begin to steadily decline within seconds after heat is applied. If the NTC thermistor follows this behavior, then it is good. If it does not, it is faulty and should be discarded. To test a PTC thermistor, check with an ohmmeter the thermistor without any heat applied. With a PTC thermistor, at room temperature or below, the thermistor should measure a very low resistance. Now apply heat, just like before. The resistance of the PTC thermistor should gradually and steadily rise within seconds of being applied. If the resistance increases steadily, then the PTC thermistor is good. If it does not, then it is faulty and should be discarded.
Conclusion: thermistor sensors are temperature dependent resistors that change resistance with change in temperature. They are very sensitive and react to very small change in temperature. They are best used when a specific temperature must be maintained and when monitoring temperatures within 50 Celsius of ambient temperature. Thermistor meters, as part of a temperature control system, are the best way to measure and control the heating and cooling of a Peltier device. Their ability to adjust per minute allow for maximum system ability. Thermistor can be integrated or surface mounted on the device, requiring temperature monitoring. Depending on the type, they can measure liquids, gas, or solid.